Welcome, welcome to all of you uh, in this in this presentation. And this presentation is in continuation to the previous one. We have been trying uh, to go in some kind of philosophical mode of physics in general. And in the previous video, the I was talking about the evolution of the universe. Uh, what are the plausible and probable theories are there uh, that are demonstrating that what could have been the ways, what could have been the origins by virtue of which the universe has come to in the present state. So I talked about the basic theories, steady state theory, I talked about oscillating theory, I talked about the mostly accepted theory, it's widely accepted throughout the globe, that's the Big Bang theory. And apart from that, we have other theories, and multiverse is one among the other theories where you probably predict that inflation could have given birth to the bubble universes. So there could have been a range of universes that were grown out of inflation with probably the different set of uh, laws invoking in those universes. The problem is that you cannot experimentally confirm those models of the universe, but anything is possible. So uh, there are other theories like we have plasma cosmology theory, we have quantum fluctuation and vacuum energy theory, and probably string theory that tries to give us the implication for the universe. And if we have to demonstrate that, I mean, uh, uh, this comparison, if I have to make an overall correlation, that what's mostly accepted as a theory, maybe the most acceptable theory tomorrow maybe the time when another theory will come and it will demolish the predictions of the Big Bang theory. So Big Bang theory it is supported, it has evidences, and it has two important evidences. One is cosmic microwave background, and then there is the redshift. And the steady state theory that I talked about in the previous video, this theory is purely rejected because it lacks the observational support. There's no observational support for this steady state theory. The oscillating theory that I talked about, where you have the growth of a universe, then there is again the compression, and then there is another start of the new universe. But what observations tell us when we talk about the Hubble telescope, the observations tell us that the universe that we are looking at, it is expanding, so we are not able to see any kind of contraction in the universe. So this oscillating theory of the universe is speculative. Now, I'm not a biologist, and I'm a physicist, so, but still, I feel that I can talk about some of the important aspects, because when we go into the domain of astrophysics, into the domain of cosmological physics, where people try to analyze the universe that is surrounding us, the role does not confine to only physics, does not confine to only cosmologists. I mean, it goes away to the different branches of science, and astrobiology is one of the important branches that works in the field of the universe, in the field of the cosmos. And I would like to go with the definition of the astrobiology. It's basically the study of the origin, evolution, distribution, and future of life in the universe. Now, to me as a physicist, I feel a complete correlation between what exactly is attributed here in biological sense. It certainly makes sense when I start thinking in terms of the Big Bang. Now, the difference between the two is the Big Bang is it's a large time scale problem, and if you compare the biological life of the planet Earth, it is also a large time scale problem. But the Big Bang seems to be the father of the biological state of evolution that we have on the planet. So the things that I'm trying to talk about here is that they are purely rational in nature, they are purely scientific in nature. There is no inculcation of any other kind of sociological philosophy that I intend to talk about here. So here I'm talking as the student of science, what the observations of the science are. So as I talked about the astrobiology, it talks about the evolution. So in physics, we also have the evolution of the universe, and certainly there has to have a greater degree of connection between the two philosophies. And if I have to differentiate the two philosophies, Big Bang, it starts with very, very minute kind of things, where you have the observance of neutrons and protons. But when we talk about the biological life, there we start talking about the things that evolve from some simple kind of biological life, and that goes on making the complex life as things evolve in the context of the science. So what are the key questions that can be asked as if you are an astrobiologist? I'm not an astrobiologist, I'm a physicist, so it certainly does have to take a lot. It really has a deep connection between the physical philosophy of the universe and the philosophy that's there in the form of the life. So the very first question is, how did life begin on Earth? Is life possible elsewhere in the universe? And what are the conditions that are necessary for life to occur? So these are the fundamental questions an astrobiologist will ask him or herself, that how life began on the planet. Is there a possibility of life having outside the domain of the planet? And certainly, what becomes the fundamental question of this field of science is that what could be the plausible conditions? And under those conditions, these are certainly the environmental conditions, the conditions of having those important elements present in that state where the life would have started. So it's something, if you look at this picture, the life needs some of the important fragments. You cannot have the biological life unless you have a situation where you have proper and proportionate execution of operations taking place. And you can see there's a need of energy. So for energy you will always look for the sun. There's a need of water, and there's the need of these ingredients. So this picture is trying to tell us that come on, the biological life is possible only if the universe creates those conditions, and these conditions are fulfilled, and there is a very good probability of having biological life. Now, if we think about that how the life could have emerged, there are a range of theories, and 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 what is the hypothesis on how life could have emerged, including abiogenesis and panspermia. And the next important thing is that uh, of habitability, and what makes a planet or a moon uh, capable of supporting life. So these are the fundamental questions. They are not the questions. You're looking for the answers to these questions. And you have infinite state of data available that you are trying to analyze that what's going on. And this is what we call what we call as Goldilocks zone. So this habitability is what is called as the Goldilocks zone. And there's a possibility of having planets other than that of the planet Earth, and moons within the solar system where there's a possibility of having life. So we must be in a position to search the planets like Earth, the moons, the icy moons that could support life. So these three fundamental uh, arguments, the fundamental points, they make up the basic bone of thought in us that what's the direction through which we are supposed to move on. Now, as I said about the abiogenesis, and what is it? Life originating from non-living things. So when you exactly try to look at the life, you have a range of atoms. Everybody is made of atoms, and there's a collection of atoms involved in making a biological system. And it would rather be the best starting point for anybody who is in the field to think about the possibility of life, that it could have certainly emerged from the non-living matter, uh, and possibly in primordial soup or at the deep sea vents. So there could be a lot of hypotheses that could be invoked uh, to to have the complex kind of life that there is a range of evolved life on the planet Earth. It can be attributed here, at least from rational point of view, that it has originated from some non-living matter. And it's not like that non-living matter is the only execution of forming these complex organisms. They need those important environmental conditions that could have supported the formation of life. So this is what's called as abiogenesis. Now the next is panspermia hypothesis. And this hypothesis certainly has to do a lot with astrobiology. Life on Earth may have been seeded by some extraterritorial object. Maybe there was no life on the planet, and there have had been the right conditions, right environment, right temperature, and a seed in the form of matter might have come from some extraterritorial region in the form of a meteor, in the form of an object, and maybe those debris that have come from the outer extraterritorial universe might have hit the planet Earth, and then having the Goldilocks situation on the planet Earth would have led this meteorite to transform into the micro organisms, and then you have a long story of that evolution from science point of view. So panspermia hypothesis is another attribute. The next one is the deep sea vent hypothesis, and this hypothesis what's the basic argument of this hypothesis is that life could have originated in some energy-rich environment near some hydrothermal vents. I mean, if we look at the planet, we have sea, we have oceans, but beneath these oceans, they happen to have the regions where the tremendous amount of heat is coming out from the core of the earth, and maybe because of the presence of those basic elements that we can see in biological life, maybe those elements would have been present in those near to those vents, and these vents have given right support to the formation of the complex molecules in the form of life. Now, these are the three important conditions that anybody can think about as long as the biological life like that of the planet Earth is concerned. There can be the life which is biological, but it might have different origins. It might have different kind of environments. It might have different kind of basic structure. But if we talk about the life that's there on the planet Earth, we understand what are the basic plausible mechanisms, what are the basic plausible sources that we need for the creation of life, for the life to exist on this planet. And nobody can doubt about the water. And water is an ingredient for life, as it's a solvent that supports the biochemical reactions. And we need an energy source. And our energy source is sun. So life requires energy, and which could come from sunlight or the chemical reactions or some geothermal sources. And certainly there has to have the presence of these elements that you have. You can't have life if you have carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These are the essential elements of the life. So wherever you think of the life like that of the planet Earth, these are the three important basic conditions. And if these three conditions are met by a system, by a geography, then certainly we can presume that there is a possibility of life on that planet, on that moon, or whatever the thing that we are talking about. So we are in search of life, and the closest to us is the Mars, and there are evidences of past water and signs of possible microbial life that could have lived on the planet Mars, and there are missions going on. And Perseverance rover is an example that has been sent to the Mars, and the photographs of the Mars are continuously taken by this rover, and the experts are analyzing these photographs that are sent by the rover, and trying to predict that what could be the plausible mechanisms that might have evolved on this planet. Maybe this planet has already come to an end where the life would have existed long back, and then due to the changes in the environment, the life might have exhausted down. So Mars is an important target, and this target is being explored by the developed countries. Now, so at the same time, the Mars is something that's close to us. It's within the solar system. It would rather be a wrong argument if I will say, come on, you cannot have life on any planet, on anything that's existing in this universe. I think it's a wrong argument, and people say it's a wrong argument because when it goes to the number of suns that this Milky Way has, the size of the Milky Way alone, I'm not talking about the Andromeda, it has the size of the Milky Way, 100,000 light years, unimaginable. Its vastness, the number of stars it has, the number of sun-like stars it has, the number of stars of whose masses are many, many fold greater than that of the mass of our sun. There is a very good probability. If I go with the least probability, that's going to give me a good number of planets like Earth that could exist in the Milky Way, that could exist beyond Milky Way. But it's not important that you can have the same format of life. Maybe life could have evolved in some different format, a different mechanism. Because we have those examples on the planet Earth where life can exist in those states where a normal biological life cannot exist. So the exploration to the exoplanets, it's of something vital importance, and there certainly must be the planets existing in the observable universe where we have those Goldilocks type of situations, and there is a good possibility of having life on these planets. The only difference for us is that for us those distances are extremely large to be reached out, and maybe in future we will have the technologies that can make a transformation to those points of life in the universe. So I was talking about the Goldilocks zone. So Earth is a Goldilocks zone. So what's the definition of the Goldilocks zone? You can see the habitable zone is the region around the star where conditions might allow liquid water to exist on a planet's surface. So an astrobiologist is looking for the Goldilocks zone. So if there is an indication of Goldilocks zone, then certainly that's a target for an astrobiologist to look for and to investigate. And Earth is a Goldilocks zone of the sun, and we have discovered the exoplanets in the habitable zone, and Kepler 45-2b is one, and Proxima b is another, while it is presumed that maybe there is some kind of biological life existing on them. So this is how the Goldilocks zone should look like. I mean, you have planet Earth in the Goldilocks zone, and everything best is happening for the planet Earth so that it can persist, it can give birth to the life, it can evolve life by virtue of the external agents. The life on the planet is not working only because of the planet Earth. It has its origins in the galaxy. It has its origins in the solar system. And if we rightly say the life on the planet Earth is because of the right distance, it is from the sun. So for any planet to be in the Goldilocks zone, there is a need that this planet should be in the Goldilocks zone. That means it must be at the right distance from the sun so that sun allows the water to exist, the water to be there on that planet in liquid form. So this is our Goldilocks zone. Now, extremophiles, organisms that thrive in extreme conditions that I was talking about, that on planet Earth we can see a range of organisms that can survive the extreme conditions. And for under those extreme conditions, the general type of biological life that we have on the planet Earth, it's not possible for that life to exist in that format of life. And what are the examples? Thermopiles. These are the hot springs and halophiles, these are the salt lakes, and acidophiles, these are acidic environments. In all these types of environments which are not plausible for the common biological life, there we can see the microbial life can exist, and giving us an extra idea that we cannot be searching for life beyond this planet only in the form of the biological life that we have. There is a probability that there can be different, there can be life, but that life can survive some extreme conditions, as we have examples on the planet Earth. Now, life could exist in extreme conditions on the other planets or the moons. So their existence is a starting point for us to realize that you can have the places in the universe when you can have the life, but that life can be in the form, can be originated from anything different than that of the Goldilocks situation. So you can imagine life where you don't have exactly the same kind of support by the sun, you don't have the same kind of climate that you have on the planet Earth, and maybe there are different kinds of involvements from different categories which we are not aware about, and there is certainly a possibility for the life to exist, even though you don't have water, but you have salty water. Even though you have acids, you have those extreme conditions that we can see even on the planet Earth, and you can imagine the life beneath the snow, where the temperatures are extremely low, but still under those extreme conditions, there's a possibility of having life in that form. And what missions astrobiologists do have, they have Mars missions, space telescopes, and search for extraterrestrial intelligence, scanning for these alien signals. And we have missions, as I talked about. There are a range of missions on Mars, and India was the first to send an orbiter to the Mars, and that was a great achievement of the country, sending a satellite on Mars and receiving some data from that planet. And in space we have James Webb Space Telescope, JWST, and it is analyzing the exoplanets, analyzing and trying to look for those Goldilocks zones that could exist in the universe, and certainly may discover more planets, may discover more moons in the solar system where there is a possibility of life. So SETI, there is always search for these extraterrestrial intelligence, and we have lots of fiction movies that have become blockbusters in the world by presuming that there is some kind of extraterritorial alienism existing in the universe, and maybe they exist, but there is no complete evidence of such kind of thing. Now, what are the basic challenges of these astrobiologists? I mean, what I believe is that science should flourish in a way where you have a person from different fields coming together and planning a model of that science. Now, the physicists should be part of the biologists, and then they should be the part of the other kind of sciences where people should work together and look for solving a problem. So, what are the challenges? The first important challenge is the distance and the exploration, and the closest that we have talked about, the Proxima 24, it is nearly 4.2 light years away from the planet Earth. So physical exploration of these planets is not possible as long as the current advances of technologies are concerned. So defining life. So what exactly constitutes the life? So is it the only way that you can define the life that's there on the planet Earth? Or there could be some other kind of element that can have some other kinds of environments, and that can have different sources of energy, and they can lead to a life, but that life does not have the same basic module as that of the life on the planet Earth. So the important point, what exactly constitutes the life, especially if it is based on the biochemistry unfamiliar to us. So maybe there's a different kind of chemistry involved which we don't understand, and we have the technological limitations. The current space missions and equipments may not yet be advanced enough to detect anything beyond the planet Earth. So, what is the future of an astrobiologist? I'm not an astrobiologist, and I talk about it because I'm a physicist. It certainly makes sense when I try to superimpose the biological sense of thought on the physical sense, on the Big Bang, on the universe that's evolving, on the planet that's going on. And artificial intelligence, I mean, there's a huge data available, and maybe artificial intelligence can do something great. It could help in analyzing the large amounts of data from space missions and have some predictions about the plausible life that can be out there. And new discoveries and continued advancements in the telescopes is needed, and space missions could bring breakthroughs in the search of extraterrestrial life. Now, my final thought on this field, so it's a brilliant field. It certainly needs all science behind it to look for anything that's biological in the universe. It certainly fascinates the nation. And India should also go in the direction of astrobiology, and at the same time, I will advise for the quantum computer at a large scale. So, astrobiology combines biology, chemistry, physics, and astronomy to explore the potential for life beyond the Earth. The search for life in the universe continues to inspire the scientific discovery. The discovery of life beyond the Earth would revolutionize our understanding of biology, our place in the universe, and our future. And with this, I would like to end this talk. I hope everybody is fine. So goodbye and good luck.